Hello, everyone, and thank you for joining us on our next session of MODSIM with 3D Experience Works series. For those of you who are joining this series for the first time, my name is Sri Krishna Chittur. I'm a part of Simulia brand of Dassault Systems, and this series is specifically meant for decision makers and engineering managers at various product development companies that are currently using SolidWorks as their primary CAD environment for innovating really cool products. With me, I have Stefan Sier. Stefan he has an interesting engineering background. I'll let him introduce himself, but he's joining us as a user of electric bike today, which is why I'm super excited. Stefan, why don't you provide a quick introduction of yourself?
Yes, hi, Shri Krishna. Hello, everyone. Yeah, my name is Stefan Cyr. I'm also part of the Simulia brand inside Dassault System. I'm responsible for the team that is producing all the training material for Simulia, but today it seems that my expertise is more on the user of the e-bike experience that I'm going to contribute to this discussion. And yeah, it's with pleasure that we'll be talking about the development of e-bikes and all the tools that can be used to develop such a product.
Okay, thank you, Stefan. And thanks again, everybody, for joining the call. Let's go ahead and get started. We'll first do a quick introduction of what is an electric bike, what is the current market, and what are the requirements. And we'll talk a little bit about the MODSIM approach of Dassault Systems to address challenges associated with product development process. And then we go right into how to make electric bikes lighter, manufacturable, more efficient, less bumpy, and compliance ready. That said, for those of you who are new to electric bike, I mean, everybody knows what electric bike is. There's a pretty growing popularity of uh, bikes that come with an electric motor and that are powered as opposed to the traditional bicycles, right? And we are seeing this sharp rise in demand, especially for green urban mobility. We are seeing micro mobility as a service where you can pull up your phone, use an app on your phone, scan the QR code that's on an electric bike, and then ride the bike for however longer you want to, and then drop it off at a point, and then you're only paying for that service, right? So it's like a pay-per-use business model that has been very popular. I mean, there are some famous companies that started with a scooter like Lime in the US, but now this has expanded beyond mini scooters. And we are also seeing a lot of tech savvy consumers. People like not only riding electric bikes, but also the tech that comes with it. Being able to track the distance, being able to track the location, and the IoT stuff. So, Stefan, you have been the user of electric bike for quite some time. What's your general
Yeah,
thoughts?
so we can make a distinction that there's, I would say, two kind of electric bikes. I think most of them, or many, are electric assistants.
Mhm.
Okay, where you basically need to pedal in order to get the motor to reduce basically the load on, or the effort to ride the bike. So it's not like a scooter or a motorbike that you press a button and you just
Oh,
advance.
yeah.
Then there is the second technology where you press a button and then you can just accelerate it. But these are more like little electric motorcycles, I would say, or electric scooters. The one that I'm using is electric assistance.
Mm,
So you need to actually pedal,
mm,
but then you can adjust the level of assistance that you're requiring, some different level of assistance. So from the really minimum, which will not use a lot of electricity, to a large assistance where you barely put any effort into the pedaling. And it's to me, it's what's nice about this is that it allows you to use your bicycle in a wide range of environments. So you can, if you're just riding to the grocery store, then you can have very little assistance. But then if you live in a neighborhood where you have a lot of hills, then basically you can ride your bicycle without getting all sweaty. And in fact, it's basically why I bought first my bicycle. I was living at the time, so that was 7 years ago. I was living in Stuttgart, in Germany at the time. And Stuttgart is a very hilly, so it's in the valley, basically surrounded by some hills. And I wanted to ride my bicycle to work, and I was living in the valley in downtown, but then my workplace was uphill, and basically having the bicycle like this with a lot of assistance to ride the steep hill to go uphill. Then I was able to get to work without having to take a shower when I was getting at the office. So that was my main motivation. If you want more details, so.
No, that's good. Yeah, that's good to hear. And is it fair to say that most consumers who are using the assisted bicycle or the semi-assisted electric bikes are people who actually buy these bicycles and use them on a daily basis, versus the second category that you explained, which is like almost fully automated, that being more, more of a service being provided?
Yeah, if I look, most of the people that I know that have electric bicycle have the electric assistance version.
Mm-hmm.
So I have members of my family that also are using the bicycles, the electric bikes, but to do cyclotourism. And what the electric bike has brought is really democratization of the usage of the bicycle. Okay. Bicycle used to be okay for, I would say, younger people, or but now what it brought, it's basically the ability to go do, as I was saying, cyclotourism. And then you can have in your group people from like very fit people to not so fit people. Okay. And it basically allows you, or a whole group of different people with different, I would say, physical fitness, to basically be part of the same group, different assistants inside the group. And it allows you to, yeah, to everyone stays together and enjoy the activity together. An example, last summer I was with my family. We were visiting, so we went for a ride like this in the countryside. It was in France, and it allows you to basically ride, and at one point you say, oh, there's a nice little church on uphill there, and then everyone, okay, yeah, you go there easily with this very diversified group of people with different levels of, as I say, fitness. And then you can just go, basically it really adds a lot of flexibility to the usage of the bicycle. So this is what I find very attractive with this type of electric assisted bicycle. And I think many people enjoy riding the bicycle. So having the fully electric, I would say, scooter version is not as enjoyable as really riding the bicycle.
It's more of a fun, convenient way to get from point A to point B.
To point B, but it really, as I say, increased the groups of people that can access this, because now you can be like older people, retiree, or that wants to enjoy a bicycle ride in about any type of landscape, and you're able to do it. Okay, whereas when it was just a single regular bicycle, you usually need to be quite fitted in order to be able to go wherever you want. So
Now, with any new technology comes challenges and some of the requirements. We've laid out some, hearing from different customers, different users. I think the top five being lighter frame, but also strong at the same time for a reliable commute, extended battery range, so you can ride longer, lighter, quieter motor, delivering maximum torque, compliant, ready. I think this is more from a OEM standpoint as opposed to from a user standpoint. And last but not the least, the smoothness of the ride. Which of these do you think matters the most to you as a regular user of an electric bike?
so definitely the lighter frame is an important one for me. If I look at my bicycle, I say was I bought it about 7 years ago, and I think it's a German company that developed my bicycle.
Mm.
If I look, they really over designed everything. Okay, so I think they wanted to be on the safe side. So and saying, okay, it's an electric bike, it's assisted. So even if it's heavier, you just need to increase the assistance. But typically, the bicycle is probably something like 60 pounds, or
Oh,
it's
wow. Okay.
it's
It
quite
is
heavy.
heavy. Yeah.
Okay, so at the time when I bought it, I was living in like a building with and the storage room where I had to put the bicycle. I don't know, it was 10 step to go
Okay.
up to, but still, like, this is quite a heavy bicycle. When you're riding it and you put the assistance, you don't really feel it, but definitely they over designed the frame,
Mm.
and it's really very heavy. The motor is and battery, of course, are also part of this, the contributing to the weight, but the structure, if I look compared to the design that we see here on the screen, all the membrane or all the parts of the frames are basically more of the order of the central bar that we see
Mm.
than the smaller one there. So so definitely this company would have benefited from doing simulation to try to optimize the frame to
Mm.
and of course, the heavier they are, also then when you're riding the bike going uphill, and you basically need to put the energy to bring this heavy bike uphill, and so it's also contributing to the range that you can reach with one charge of the battery. So making the frame lighter definitely has benefit on the usage of the bicycle at different levels. So
I think the good news we have is that, especially for our SolidWorks users who are developing really cool electric bikes across the globe, is that they now have access to the MODSIM approach offered by Dassault Systems. What is it? In very simple terms, SolidWorks CAD users now have access to a whole portfolio of solutions coming from different brands of Dassault system, including CATIA for some design applications, Simulia for simulation technology, which is what we'll talk about, Innovia for governance, and Delmia for manufacturing, and so on. And all this is being offered while being fully integrated inside SolidWorks, or in an interoperable environment with SolidWorks, meaning you can make design changes in SolidWorks and then update your simulations, manage the simulation data on the cloud-based 3DEXPERIENCE platform, which is one-stop shop solution for different aspects of product development. But today, we're going to talk about bringing modeling and simulation together. Modeling with SolidWorks and simulation based on Simulia technology that's being offered on the platform. And to be honest, a lot of people are already familiar with the name Abacus for structural simulations. That's exactly the technology being put on the 3DEXPERIENCE platform, with a more nicer workflow that's integrated with SolidWorks for structural simulation. We also have solutions for thermal and fluid flow performance optimization, plastic injection molding, which we'll talk about later, electromagnetics, which is going to be key for innovating any electric bike. Last but not the least is motion simulation for ensuring a smoother ride. So today we're going to talk about all those different disciplines in the context of the requirements that we started with: lighter frame, lighter motor, extended battery range, being ready for compliance or checking if the product is ready for compliance, and last but not the least, the ride being smooth. That said, from a collaboration standpoint, and this is more for OEMs, with the 3D Experience platform, what I really liked is that you can track the project end to end while having all the key information and all the key stakeholders in one single place. So this is Innovia based project planning application on the platform that's basically showing what are all the tasks, who are the people that we have assigned this to, what are the geometric models that they need to work with, what is the timeline for the projects that they're working on, and what is the overall schedule of the project, presented in a nice Gantt chart. These requirements being captured. So we are starting all the way from the top. We are not talking about 2 point solutions. We are not talking about just simulation, but we are talking about how to manage the overall improvement of a product, starting from overall summary, then going into tasks, schedules, the timelines, and who are the people who are going to be actors or who are going to be participants in this project. This is a quick view of how a dashboard looks like, which has all the information needed from development release cycles to collaboration to planning to simulation results, and then notes being shared and traded off between different people with no exchange, no import or export of files, no change in environments. You're all in one single environment collaborating with each other. Your geometry still comes from SolidWorks, which you can review, but you can perform simulation on the 3D Experience platform and share the results with all the stakeholders. This is going to make a huge difference among electric bike manufacturers, especially because in general, what we have seen from an OEM standpoint is that battery is outsourced from a third party, electric motor is outsourced to a supplier. What the manufacturer is doing is focusing on the meat of the electric bike and then also focusing on the integrated performance, be it with the installed condition of the battery and with the installed condition of electric motor and so on. So
Yeah.
what we're gonna,
So
yeah,
yeah,
go ahead.
just rapidly, one thing is that since the communication, everything is done on the platform, you don't rely on emails exchange, and
Oh,
so basically you send the you can communicate with the collaborators there directly. You get your notification when you're connecting to the platform, and you can see, okay, what information was exchanged, what updates were made. So this integrated environment is really changing the way you communicate and you work with others on project.
yeah, absolutely. And you can have different visibility for or different type of dashboards for your internal communication within the organization, communication with the partners, and maybe even communication with the users. If you want to directly collect feedback from the user, where they take a picture of something that broke, right? Maybe some part of the frame where they're experiencing a lot of failure after, you know, 400, 500 kilometers of ride. Probably they take a picture, upload it on a community saying that, hey, my name is user A from this location, and this is an issue I'm seeing. That could also be captured and considered in the product development process, right? And that's a very powerful tool to have, being so closely connected to your users. So that said, what we're going to talk about is the different models and simulations coming together to address the requirements that we started with. And we'll first kick off the most important requirement, which is being tightly integrated with the CAD, being tightly integrated with model. So that's our SolidWorks, for our SolidWorks users, that's being super close to their CAD environment. So in this next clip, what I'm going to show is how you can continue working on your traditional SolidWorks desktop for 3D CAD modeling, but you can access 3D Experience Cloud in the click of a button. So what I have here is the assembly of the electric bike, of an electric bike. And then I'm able to bring this assembly into the 3D Experience Cloud environment by first saving it, right? So I'm not exporting a file or importing a file. I'm just saving it on the common collaborative environment of the 3D Experience platform. And then all I have to do is launch the appropriate application for performing simulation. For example, if I have to perform a structural simulation, then I'm going to launch the associated or corresponding application that does it. And now this geometry that I saved is automatically brought into the cloud-based environment of 3D Experience platform. Right? And we can take advantage of the interoperability between SolidWorks and platform to make as many design changes as we want based on the simulations. So I think this is going to be a big value from a simulation standpoint for the mechanical designers who are working on making the product lighter, more manufacturable, efficient, and so on. So that said, Stefan, you said strength and durability is definitely a top priority for you as a user, right? Um,
Yeah, basically riding in, I think any country now have different road conditions. So you're really subjecting your bike to periodic loading of different kinds. So there's potholes, I would say, probably in every country. And yeah, definitely you need to have a frame that will sustain all these different loads that you encounter in a typical ride. So definitely being able to, and looking for the lighter structures that we were discussing, yeah, definitely you're going to reduce the size of the members of the frame, and then yeah, there is basically some trade-off that needs to be assessed, basically. Okay, and that's what the durability and the mechanics engineering role will allow you to do through the simulation.
Yeah, and for a electric bike manufacturer, this trade-off is pretty challenging, right? You come up with a design and then you physically test it, and if something breaks, you go back to the design table, redo it, and that's very painful. That's where the role of simulation really comes into picture, which is reducing the iterations between product design and physical testing. But having a simulation solution is not enough. You need a solution that's really, really robust, that can give you really accurate results while being so close to your design environment. That's exactly what durability and mechanics engineer role on the 3D Experience Works platform offers. It brings the famous Abacus and FE Safe technology for doing stress analysis as well as durability analysis, which are equally important to not only study the strength of the product but also the life of the product. And with this capability, the users can run pretty or simulate pretty comprehensive structural scenarios. One of the cases we are going to take a look at is try to assess the impact of different loads on the frame and find out if the frame is strong enough and how much lighter can we make it. Right. The first one we can do is a quick stress and durability analysis. We have loads being defined, constraints being defined on this model, and we look at the stresses at various locations. And one of the most important things that a lot of OEMs miss is, and one of my colleagues, Mark Pickering, who's a producer of this call, was talking about this topic few days ago, which is most manufacturers think that doing a stress analysis is good enough, or thinking of a SN curve is good enough. That's not true. durability, doing a thorough durability analysis is so important, because as you're mentioning, you have different terrains in which you're riding, right? You have the urban space, and then you have some sort of a hilly area, or even within the urban space, you have a nice flat road, then you have a bumpy road, you may have some potholes. So being able to account for all these different loading cycles will give you more realistic picture of how the frame is going to perform in real world conditions.
Mhm.
Have you
Yeah.
ever had a scenario, Stefan, where you feel that the frame is really struggling, or probably not in your case because it was over designed?
Yeah, as I say, I probably could drop off a 10-story high building, and I think the frame would survive. Not me, but the frame certainly. But no, yeah, definitely riding on a regular street with all what you encounter with the yeah, mainly the potholes, the cracks, and the so of course having suspension is helping also on the frames, but in so I have a configuration that is similar to what we see here. So suspension of the front wheel, but the rear wheel is attached directly to the frame, and there's no suspension element for the rear wheel. So and definitely when you want to find an optimized size and shape and try to reduce the amount of material that is used basically on your bicycle to make it lighter, then you're going to yeah, have some I would say weaker points that are going to appear, and to be able to project in the life of the product to say, okay, if you're riding 500 times, or when is it likely to start showing problems, okay, is definitely an additional way that people need to integrate in when they're developing the product. Okay, because as you were saying, just a static load analysis is really not representative of or enough of how a product is being used.
Yeah, absolutely. And in fact, what we hear from OEMs is that this has a direct impact on the warranty and recalls, right? If your
Absolutely.
if your product starts failing after a certain number of load cycles, then it also has an impact on the brand image. And we see that very commonly in motorcycles. If there's one particular part of the frame that's failing, you have somebody who goes on Instagram or YouTube, puts a video saying that, hey, this model is crap, don't buy it because it's failing right here. Right?
Mhm.
So doing these upfront analysis of both stress and durability kind of helps you minimize the chances of failure in real world, obviously backed by physical testing as we go along. Um, let's talk about motors real quick. I know this is one of your favorite topics. Do you want to quickly tell us about what you would expect from an electric motor in an e-bike as a user, and how
Yes.
make it better?
So, and in fact, there's two parts, I would say, that there's the motor itself, and then there's the controller. That is as I was saying, I'm using a model that is electrically assisted, and basically the motor is assisting you to a certain level, but then up to a certain maximum speed. After, I think, when you reach 25 kilometers an hour, the assistance is basically or stopped basically. So it's stopping at the, so you cannot reach excessive speed with the assistance. But definitely in for the on the weight side, then all the elements that are included, many metallic parts are used, of course, in an electric motor, and the positioning of the magnets, the winding, the core, also material that is used, the lamination that is used also inside the motor. These are all aspects that can be parameterized when you're designing the motor, and then you can with our simulation with the CST solver, you're able to get the electric force or the torque that you'll be able to get as a function of the current that you put in the motor. But you'll get also all the electromagnetic emissions that are associated with the motor being running basically. And so these are two aspects. So definitely the torque that you get out of your design. So trying to optimize both the shape of the different elements in order to get your maximum torque with the minimum weight that you want in your design. And then also to make sure that you're, when we'll talk about the compliance a little bit later, but you need to think that these electric devices like an electric motor are creating emissions, and they also need to be within some compliance certification limits. So all this can be basically simulated with the CST solver that we have
Yeah.
with this electromagnetic engineer role.
Yeah, and what's exciting about this is SolidWorks CAD users have always had access to a desktop simulation portfolio, which offered capabilities for structural, flow, plastic simulation, but not electromagnetics. So EMAG is really new to the SolidWorks CAD customer base. And the fact that we are leveraging the industry standard CST technology, putting this very powerful technology in the hands of mechanical designers of SolidWorks, that's very exciting for me. And as we go along, the other important aspect, especially while developing the motors, is being able to perform different trade-off analysis or trade-off studies, right? And correct me if I'm wrong, one of the most important things is being able to get a smoother acceleration when you are in the assisted mode. Is that it? Yeah.
Yes, so electric motors can basically, depending on the configuration, so you have the winding on the stator, and then you have your the rotor where you have permanent magnets in a configuration like this one, and different combination, different I would say orientation of the different elements is going to produce different outputs. Okay, and one problem that can be encountered with the designs of electric motor is the rippling effect that is called, where you don't have a smooth torque output, but you have some fluctuations that are introduced when operating the motor. So all these can be identified during the simulation process to make sure that the elements are not just producing the average torque that you're looking for, but also a smooth one. So.
Okay, yeah, I mean, in this case, as we can see that a geometry is created in SolidWorks, and then it's brought on to the electromagnetics engineer role to perform the simulation of a permanent magnet synchronous machine, or PMSM type of a motor. And we're just looking at a trade-off study in terms of the highest torque and ensuring that it has the acceptable level of torque ripple. What I really like about this is for a engineer with minimal to no background in electromagnetics, you can still perform really nice trade-off studies, and it can be based on different types of requirements. You can basically rank different designs and say that, okay, I'm going to go with design 1 because it looks like it has met some of the key KPIs, engineering KPIs, that make the most sense for this requirement.
Yeah, exactly.
All right. Moving on from the motor, let's talk about battery and how important is having a good battery range to you as a user of the semi-assisted e-bike.
I would say when you're doing just urban riding, as I was like if you go to the grocery store, or so if the distance you're not or you're traveling are not too big, I would say range, of course, is not as important. But this is where you could have also different packs. Okay, if you're doing really urban usage, and then you want to reduce the weight of your overall bicycle, you could have like a city pack, and then you could have a longer range pack. The family members that I was talking about that are doing cyclotourism, for them it's extremely important. Okay, so they are traveling 100 or more than 100 kilometers per day, and definitely to be able to reach point A and make sure that you're reaching point B at the end of the day on your charge is very important. Especially, I would say, my bicycle, if I'm running out of the battery and I need to start just pedaling on my own, then it becomes exhausting, basically. If you don't have the assistance, then when you lose, it becomes a very painful effort to ride the bicycle. So the range is definitely important, but as I say, mostly for when you're doing the longer distances.
And with range comes the engineering challenge of managing the overall thermal environment inside the battery. You don't want the batteries to get super hot and go into thermal runaway, which causes all kinds of safety issues. At the same time, you don't want to overcool the battery and not get the optimal performance. Being able to study this trade-off between how do I ensure that the surface temperatures of my cells are within the, or the overall temperature of my cells are within the acceptable limit, these kind of questions can be answered with the fluid dynamics engineer role on the 3D experience platform, where you can explore many designs and assess if the thermal performance is within the acceptable limit. And what we did here is we took the older model of the battery pack and then just added another module in order to increase the range. But it's not just a simple CAD job. When you add another module, you have to reassess how thermally efficient is this pack going to be. So with the help of a assistant panel, you can very quickly set up the thermal simulation on this 4-pack module. Initially, this was a three module pack, and we added one more. And in this case, we're just looking at what are the cell surface temperatures with a casing that has no slots and a casing that has some slots for natural convection cooling, and we didn't find much of a difference in terms of the maximum temperature, which was well below 30 degrees centigrade. And that's quite important so that the cells don't blow off. And this is only one of the types of analysis. Another important thing is we also study the transient ramp up of the temperature for different drive cycles. For example, if you're accelerating uphill, then it's a different load case as opposed to if you're accelerating or coasting through urban city. So being able to study all these different scenarios while being closely tied to SolidWorks CAD environment, that makes a huge difference for a electric bike manufacturer who's currently using SolidWorks in their design process.
Yeah, so this conjugate heat transfer calculation, so being able to do both the thermal and the fluid calculation at the same time, and getting information from the fluid to the thermal calculation. So because from the fluid you basically get what we call the heat transfer coefficient. So how the efficiency of the flow to basically remove and carry away the heat from the around the cells themselves. So to be able to do the two together is very important to get an accurate solution. So and here we have basically, I would say all kind of heat transfer coefficient that is taking place. So we have the generation inside the batteries, we have the convection, the conduction, and I'm not sure we probably didn't do a radiation in
Radiation, probably not so much in this
probably
case.
not because it's not so high temperatures and it would be neglectable here. But to be able to do all of these mode of heat transfer calculation and getting the right information from the flow that is basically being established inside the cavity is quite important.
Yeah. And also another thing that you may notice is that the casing here is actually made out of plastic. And typically when we talk about plastic, majority of the times it's manufactured with the injection molding process, where you have two molds come together, or two halves of the mold come together, and you inject molten plastic at a certain pressure, let it fill, let it cool, and then you eject it out. Um, it's equally important for an OEM to make sure that, especially a designer working on a casing like this, to make sure that it's also manufacturable. It not just looks cool or fits with the batteries, but also something that can be manufactured at a really large scale. And the good news is we have a really nice solver that it's called Simpo, and that's what's used on the 3D Experience platform as well as SolidWorks Plastics. Um, and this is offered through a role called plastic injection engineer, where a mechanical designer can very quickly assess if this particular casing is manufacturable with the injection molding process. What I really liked about this plastic injection engineer role as opposed to SolidWorks Plastics is that it's using Abacus technology for warpage part of the simulation, which can get you really accurate estimation of how this plastic part is going to behave as soon as it comes out of the mold.
Yeah, so you have the warpage and you have the shrinking also indication.
Right.
I must say, so my background is more fluid mechanics, and I did a lot of flow simulation. But before joining Dassault System, I never really did plastic injection. And so I was involved in some of the simulation here for the plastic injection of this casing. And it was really my first experience with the role and the apps. And I was really surprised by the basically the ease of
Ease
use
of use. Yes.
of the tool. Okay. So you basically define what you call the gates, so the injection points.
Mhm.
So that is done very easily. So you identify that on your geometry. And then you have a wide range of materials that you can use. So all this is in a database. So you don't need to, or you basically need to identify the type of plastic you want to use, but all the rheology, all the information needed to do the simulation is available through this database of material. So you select the material you want to inject. And then basically there are parameters like the pressure that the injection pressure that you will use, and the temperature also of the mold. And then you can basically identify all potential problems that you will encounter during the injection process. And it's very, very easy to use. And as I was saying, I'm not a specialist, and with a little bit of training and some information, you're able to get ready and basically do your simulations and get useful information on the manufacturability of the part that you have designed. So
So I believe we typically look for defects like, is this mold good enough for the plastic to fill? If it does not, then there's a short or
yeah,
inability, right?
so basically what you refer to as the short shots are identifying inside the mold or the cavity if the plastic will be able to reach all the corners and or if at one point it will just stop, and because you have too much of a taper or the space is too small, then the plastic will not reach the end of the cavity, and you won't be able to yeah, to fill the or have a nice casting of your part. Another thing is so when the filling pattern, okay, so if you have a front that is ending and then the flow is coming back, you will see on the surface of the finished part, you will see like a seam, or you will see a line.
The knit
uh
lines.
Sorry.
The knit lines.
The necklines, yes. So I was so basically it's all things that you can identify, because you typically want to have your plastic flowing from the injection points to the basically to the exit or to the other part without having reflows or a front that is freezing and then having plastic that is filling coming back to fill the cavity. So all this can be identified during the simulation. And as I say, I was not an expert, and now I know I'm able to do a plastic injection
That's
simulation.
That's
And
true democratization of simulation, being able to
yeah,
put these
absolutely.
powerful tools in the hands of users who don't come from that background. So that's good to hear. And I completely agree with you. It's the ease of use, having this access to massive material database, because that's everything in the injection molding
Mm.
world, where the user should not spend any time trying to secure the rheological data. And from what I have heard, I think we have about 4,500 plus latest and greatest materials that are available in our library, because DESO has partnerships with so many
Wait,
plastic material
it
manufacturers
will
around the
occur.
globe. So that's very encouraging.
Yeah, so this is not our specialty to basically the development of plastic material, but we are working with partners that are basically this is their domain. And they measure, they have all the accurate characterization of these materials, and basically they we use their data to build our database. So
Right. And another thing that I liked is that in SolidWorks, we created two configuration in this case, one casing without the slots, another with the slot. As soon as we, first we set up baseline simulation, both for the battery as well as the plastic. And then as soon as we made the design change and created these slots, we just had to update these battery and plastic simulations, and we could do this update on both of them without, a lot of manual effort. So that's pretty cool. I mean, I think that's the heart of MODSIM approach, which is bringing modeling and simulation together, not just for one particular simulation, but all types of simulations tied to a single design.
yeah, attaching a simulation to a geometry, and the fact that when you modify the geometry, you can rerun the simulation very easily. You don't have to start from scratch again because you have a new design, and then you need to reestablish everything. Then this is saving a lot of times, and it's allowing iteration cycles that are very rapid and allowing you to converge to an optimum
100%.
solution.
I think that's the biggest differentiator, because if you look at, I mean, there are a lot of point solutions for different types of simulations out in the market for structures, fluids, or whatever, which are really good at what they do. But the biggest challenge is every time you have to import the SolidWorks geometry as a step file or whatever, and then you create a mesh around it, you apply your boundary conditions on the mesh, and then you look at the results. But now if you go back to your SolidWorks, make a design change, you have to repeat 75 to 80% of this process. You have to re-import the geometry, redefine the mesh parameters, reapply the boundary conditions on the new mesh, and that's very painful. And it's almost a no-go for a designer or an engineer who wants to get results quickly to make design changes. Right. So that said, we have about, from a time standpoint, about 10 minutes. So let's quickly talk about the bumpiness of the ride. How smooth would you typically expect your bike to be in an urban setting?
Yeah, so definitely for the comfort of the rider, the smoothness of the ride. So I would say the design of the seat basically is very important for
And
your.
also the shock absorber, I believe.
And then of course is the intensity or of the accelerations that you get while you encounter a bump or so this yeah, if you're riding and you feel all the bumps in the road and gets directly in your body through the seat, it can be not as appreciable as if you have a smoother ride. So definitely the motion, the smoother motion is a very important one.
Yeah, the good news is we have basically integrated SIMPAC solver technology onto 3D Experience platform. SIMPAC has been around the market for a really long time, especially in the automotive aerospace industry. So one of the nice things I like about this role called 3D Motion Creator is you can not only simulate the motion of different mechanisms under different loads together, but you can do this on a browser. This is a browser-based application, even though it's part of 3D Experience platform, where you can bring in the SolidWorks geometry. It can read all the mates, all the connections between different parts, and set up motion simulation very quickly and visualize the results both in 2D and 3D, which is really nice. Gives you a quick, intuitive feel for how the motion is. So here I am on a browser, and I start off by selecting the, participating geometries that are going to be a part of this simulation. And once these geometries, or we call them mechanisms in motion, are defined, then we apply then we ensure that whatever are the constraints defined in SolidWorks, are they also required for motion simulation or not? And then we add any additional constraints needed. For example, we are specifying the plane on which the user is going to be riding. uh, and 3D contacts is pretty good, which is ensuring three-dimensional contact between different parts. And that's it. Once you go through the setup process, you can then basically do a quick simulation run, which is using cloud, by the way, and it's pretty quick. So in this case, the overall calculation took very small time, and based on this calculation, we can animate the behavior with the shock absorber. Right. So it's pretty cool. Quick setup for a non-motion expert. And the nice thing is you're able to bring in most of, not all, but most of your mates and connections from SolidWorks geometry and look at the performance of the shock absorber in this case.
Yeah, so here we have a simulation of a drop, basically,
Mhm.
of the bicycle, so a certain height, and you're dropping, but you can also simulate all kind of bumpiness in the
Yes.
road.
Yes.
So if you want to have more of a ride simulation, so at the moment the road that we see is a smooth one, but you can also, if you want to have something that is something with potholes, and so you can define the road that you want, and then you would have another, like you set the bicycle in motion, and you would see uh,
The
basically the
response.
reaction of the response of the rigid body to the input or to the bumpiness on the road. Okay.
Right.
So and if I take my bicycle, for example, my front suspension has two settings. So you with a little
Fixed in the variable. Right.
so I can change the characteristic of the absorber. So I can have a much more absorbing characteristic or a more rigid one.
If yeah.
So then you can easily change the setting here in the simulation also, and see the difference that you would have. So
And that's pretty much giving a designer realistic insight into how this product is going to behave from a rider's
and
standpoint. So it's pretty
yeah.
cool. Okay, and the last part, I mean, we have probably 5 minutes left, so we'll try to wrap up real quick. The last part is getting ready for compliance, and there are two aspects of e-bike where you do have to go through compliance. First is crash simulation from crash from a safety standpoint. Second is EMC, or the electromagnetics compliance. Now, where I see simulation playing a huge role is just in evaluating whether this product is even ready for a compliance test. Obviously you don't want to make a comment that, hey, simulation can replace compliance test itself. No, at least not as of today. But you can use simulation to pretty much check if the product is ready to go for a compliance check, if the product is ready to go for compliance test, and you can catch some fundamental issues ahead of time. Before you even go into these compliance requirements, because these are pretty expensive,
Oh,
extremely
yeah.
expensive and time consuming. And if you're a small startup, then you probably are going to outsource the compliance work, right? And keeping that in mind, let's talk about two most important checks that you can do from a compliance standpoint before you actually send it out. The first one is crash. And what I really like about the structural mechanics engineer role on the platform is, again, it brings the Abacus solver, and Abacus solver is known for these really complex, nonlinear, explicit simulations where you have moving parts, where there's action. And this is one of my favorite, animations actually, because we're showing the crash test, a crash analysis of a bike hitting the wall. I know as a writer, you wouldn't make this mistake, but this is, I think, intended more to mimic what you would expect in a compliance test.
But I'm telling you that the people that are riding more the electric mountain bike type, you can get in the tree
Mm.
very easily. Okay, going downhill very fast, and so this is not unrealistic scenario, I would say.
Not
Okay,
okay.
for not for urban riding, but definitely for mountain bike type.
Right. Okay. And then the next one is the electromagnetics part. You mentioned controller earlier. And as we talked earlier, electromagnetics engineer role on the platform brings the industry standard CST solver, which is really good at not only analyzing, the previous workflow, but also with electromagnetic compliance, electromagnetics compatibility. So in this case, I guess we are basically evaluating whether the vehicle as a whole is okay from a emission standpoint, right?
Yeah, so any electric device that has some varying electric current and then are basically emitting some electromagnetic waves, and then any products that include some electric devices needs to comply to standard basically emissions. So, and this is for safety of the users in the surrounding. So, and so anything that has electric elements, okay, needs to be certified before you can sell the product. So, so here, this is, as you were saying, before you go to the certification agencies or compliance agencies to get your product to be certified and be able to sell them, then you can simulate basically the levels and exposures that you will get for the human. And here we see just in the surrounding, but we I think one thing we can say, we also have models for human exposure. So you can also have a human model that you could put in there and then see the exposure on the skin, or the level that you get for the user that is riding the bicycle. We don't see it there, but this is also something that is
I
available
think that's
in
another compliance that they
yeah,
have to address. But in the
yeah,
EMC, or the electromagnetics engineer role, we offer a library of physiological models.
model also. So,
Very cool. I think just to wrap up,
Oh,
with the 3D experience platform and using the MODSIM approach, what the users are getting is a fully integrated environment that has a designer-centric user experience, very closely connected to SolidWorks and providing comprehensive multidisciplinary simulation capabilities, all on cloud with a nice collaborative user interface where all the stakeholders can come together. And last but not the least, from a business standpoint, you can accelerate time to market with running several design iterations upfront, evaluating those design iterations upfront, innovating broader product portfolio by evaluating several alternatives, and reducing the prototyping compliance and warranty costs. I think this is really big. Otherwise, what we've seen is OEMs either over designing, as Stefan mentioned, or under designing, leading to failures and loss of brand image and increase in warranty costs. Operational efficiency is definitely more important, and we've got a really nice collaborative environment that takes care of it. Last but not the least, all these simulations that we showed are computationally very intensive and quite expensive from a IT infrastructure standpoint. But because 3D experience works is offered on cloud, this removes the cost of hardware, removes all the hardware barriers, and the overall cost of IT infrastructure. So I think we've pretty much covered all the key requirements for designing a really good e-bike. Don't you think, Stefan?
yeah, I think it was a pretty good picture of the what can be done developing such a product and the advantages of the using that on the 3D experience platform.
All right.
So,
Unfortunately, we are out of time for questions, but you can put a comment or you can write these questions on our LinkedIn post associated with this particular webinar. And I just want to, thank Stefan for joining us today. It was
my
a really
pleasure.
nice session to hear from a user and to talk about the real world scenarios and requirements. Our next webinar is going to be focused on high-tech devices. So we're going to talk about innovating super cool and connected high-tech device designs. This is going to be on 24th August at same time, and we will be joined by my colleague Hassan Cream for another exciting session. That said, thanks again, Stefan, and thanks to our producers who are working behind the scene, Sagar and Mark, and thanks to all the audience for joining us, and we'll see you soon.
Okay, nice day, everyone.